because some of you take my elective class for genetic. So, but the rest of you, I don't know, none of you. I mean, but along the way, I might, get used to. Hopefully, I can know you guys. Okay. So whoever from my class, they know that I like to engage with student. So even though I'm, you're not in front of me, but I can pick name here. Okay, I like to ask question. Okay, so I like to have involvement from student. Okay, so then we can know the feedback, and we can increase our knowledge at the same time, and also get to know you as well. Right. Um, so I expected to have 21 of you today. Your friend Melissa cannot make it today. And yeah, whoever, cannot attend the class, you can let me know. But again, for your attendance, going to be 0. So I'm not sure the consequences for that, but it's better for you guys if you cannot attend the class. It's better for you guys to write a letter to course coordinator, Prof. Jeffrey or Dr. Aini straight away. So, just let them know what's going on, whatever reason you can't make it. And yeah, just let me know. And but I'm not going to give you one-to-one session afterwards, so you have to ask your friend what we have done in the class, and what assignment that we given and whatnot. Right, okay. So for today, we are going to cover some topic on memory and the brain. Are you guys okay there? Is there any question you want to ask before we start the class? Who's the class rep?
I am Dr. Ashikin.
Ashikin, right, okay. Okay. Right. So I'm going to share my slide. Bear with me. Right, I will stop my video because my line is not that good. Right. Wait, I have to start this one. Can you guys see this slide?
Yes, doctor.
Okay, good. Right. Okay. So, right. So today, the topic is going to be the memory and the brain. But I would say that I like to start with the brain first, because the brain is the one who start first before the memory can be created. Okay. So it's better for you guys to know more about brain, and bear in mind in this topic. So we are focused on the brain and the memory. So I'm not going to discuss more on the anatomy, or how it's formed, things like that, because I believe that that part has been covered in other classes. So in my class, I'm going to go, just specific on the memory, okay? The relationship between the brain and the memory, right? So as you guys know that we have four major lobe, frontal lobe, parietal lobe, occipital, and temporal lobe. So each of these lobe have their own specific function. Okay, but again, in this presentation or in this session today, we are going to focus on the memory, the relationship between this brain area and the memory. Okay, so basically, the study of the brain, we call it as the engram, where we study the representation of a group of neuron or location of the brain, how this memory been created, or we call it physically representation of memory. Okay, so it's how it's begin is start in 1920s, okay, by Carl Lashley, where he thought like he want to study which location of the brain that responsible for our memory. Okay, so he ran an experiment where he used a metal ion um, to make a lesion in the brain. Okay, I'm not sure if you guys familiar with the metal like soldering, that we use to solder, to do soldering. Okay, it's like it's hot rod, and then he will will take out the brain of the rat, and then he will make a lesion, like um, it's not very specific, but I mean, most of the region he focused that time is at the frontal cortex. Okay, so in 1950, so he started to run an experiment where he used maze. Okay, so the trial, the rat, they try to run a few experiments. It depends on what the experiment. So either it's learning or memory. So they use a rat. So this rat will go for trial first. So the rat will go slowly to find which uh, alley who got the food. Okay, so it will, the rat will go round and round until it find the food. Okay, so but after a few trial, so the time to find the food is reduced, and when the rat learn, so that's how he justify by avoiding the alley without food. Okay, so that how he categorized that rat has learned. Okay, so for the learning experiment, so the rat given brain lesion before the learning task. Okay, so he make a lesion, and then after a few days, and then he will put in that maze, and then we'll assess whether this rat can find the food at the specific alley. Okay, so that's for learning. Okay, for the memory, so what this Carl Leslie did was he trained the rat, and then afterward he make a lesion, and after a few days, then he will place the rat on the maze, and then we'll evaluate the progression or how this rat can find the food. Okay, that's how he evaluate the memory at that time, and that was in 1950s. Okay, and but in his experiment, he found like that some of the rat can find the food. Okay, even he make a lesion a specific area. I mean, not all, but he tried to make a lesion at one spot, and then after that he moved to another spot and another spot, and it's go on and on. But regardless of the size and location of the lesion, the rat still can able to find the food, and that's what he come up with hypothesis we call it as potentiality hypothesis, where it's part of one area of the brain involved in memory damage. Another part of the same area can take over the memory function. Okay, that the hypothesis at that time. Okay, so the justification of why this rat still able to find food because of the lesion was so large with damaged cerebral cortical area involving learning in the in the main task. And besides that, of course, the rat have a different other way to find the food by sight or feel or smell. Okay, so the order come from the food. The rat can find it through the order. Right. So, but at that time, even though it's been, it's at very early study in 1950s, but at that time we don't have animal ethic. But a few, I would say that his rival or other researcher found out it's very cruel to make a lesion with that, with the hot road, I think what he did is without anesthesize. So it's been quite controversial that time, and that's how the animal ethics start to begin to be to become stronger, because they want to fight for the animal right. Okay, so even though that experiment, I would say I don't want to say it's unsuccessful, because he's the one who started the experiment. Is of course, it's always start with one step. Okay, so this experiment give some idea to the researcher to run more experiment, how to find this very specific location in the brain which control the memory. So for example, Donald had, he is actually largely a student, so he come up with new hypothesis, or we can say that a new understanding, where it's not about location but it's about the cells, where where we look at the specific area. So even at the area, but which cell is connected. Okay, so he come up with a neuron that fire together would wire together. Okay, so it's about the cell interconnected. Okay, so of course, when you always, I believe that you always say the advertisement in the television, you say, oh, neuron, what is it, neuron bersambung, when you drink the milk or things like that. Okay, so actually this is what happens. So when you have a lot of connection between neurons, so you can have more, you can create more, say, memory, for example, or learning. So that's how this information be translated into learning and memory. Right. Okay. Okay. This new example of theory. So we call it change reaction. Chain reaction is actually being it's not very recent, but this is how they try to, because at that time in 1950s, they don't know how this phenomenon happened, okay, how this neuron connected to one another, but they have the theory, but they don't know how, or they don't have a tool to prove what happened. So this is actually the chain reaction, where in one neuron here connected to other neuron. I mean, is it neuron near to the neuron which receive the information or sensory input, and after that it will fire together, will spread the information to other cells. So this model is from a pyramidal cells. Okay, and for the C, the 5 frequent divergent postsynaptic target resulting in the recruitment of large population. So that's what they said about the neuron fire together is actually wired together. Okay, this, if you can see from the diagram here, is actually is a cross correlation. This model error, actually this is a part of my PhD project, where I look at the connectivity or direction or directionality of neuron, specifically in hippocampus. So we want to know whether this neuron connected. Okay, because I'm studying. What I did was I tried to induce epilepsy in one hemisphere in hippocampus on the left side. Okay, so I want to see the spread of the seizure on the right side. So how this connection occur, or is it only one-sided, or both can be connected? So this the model, or what we say that analysis that we can do to evaluate the connection of the neuron. So if you can see here, this is cell 1 and this is cell 2, cell 3. So if you fire together same time, okay, it will give you this very sharp point here, is which means that it connected together. So, but if you say, for example, cell 1 and cell 3, okay, if you compare these two cells, they are not crossed together, not even one single action potential, or we call it spike. Okay, so there's no connection between two neurons. So this what we call it, a simple diagram to show a connection between two or three neurons. But when you have more than, of course, in your brain you have thousands of neurons. So, but we cannot measure all. So, for my experiment, okay, I injected we call it MEA, or multi-electrode array. This at the CA3 and CA1. So 4 for CA3 and another 4 for CA1. This is on the left side, or we call it ipsilateral. And this is the same electrode without the cannula. The cannula here is the function. The cannula is to inject the drug, or in my case, I injected kind of acid to create the what is it? The epilepsy to the cell, to the rat. Sorry. And then I will record, because there is no direct connection between the drug with the other side, or contralateral. So I want to know how the seizure spread to the other side. Okay, so we collect the information from both electrode, left and right. Okay, and then we try to do the cross correlation. Okay, just now what you saw just now is between two cells. Sorry. So in here, so we're comparing with 16 cells. So from here, for example, the first electrode here compared with the first electrode, of course, it will give very high correlation. Okay, you can have this here. Okay, so if you compare the first electrode, which is from CA3, and with, for example, first electrode here and the second electrode here. So this electrode from CA3 and CA IPSI and CA3 IPSI as well. So it will give you correlation, the same graph. If you just click to this to this grid here, you can see the correlation between the neuron. So this is the modern approach, or how you can evaluate the correlation between neurons. So what I want to say here, how far this had you know, theory, come to the modern era. Okay, so this what we can do. So there's a lot of other approach that we can use, such as spectrometer. Okay, and also we call it synchronization. But I'm not going to show you all here. It's going to make you confused. So I want to say that that's how the previous study can be adapt in your research these days. Right. So like I said earlier, so each of the brain area have their own function, okay, and role. So this I think you can read by yourself this the function, and we go just briefly every each of the cortex or lobe. Um, for example, the cerebral cortex, they role in memory, attention, perceptual awareness, thought, language, and consciousness. Okay, and of course, you can find this in four lobe: frontal lobe at front. That's why we call it frontal. It involves in conscious thought and higher mental functions such as decision making, especially. Okay, and it's play important role in short-term memory and also for retaining for long-term memories. And for the parietal lobe, okay, here, it's involved in integrating sensory information from various senses. Okay, so that's how you can get the information before it transfer into we call it encoding and consolidating and whatnot before it be formed into memory. And I think the most important part in the brain, which is temporal lobe, where it involves of smell and sound and processing semantic in both speech and vision. And also it's play the most important thing or the most important part in the formation of long-term memory. Okay, and for the occipital lobe, it is involved for the sight or visuals or visual and uh, uh, okay. So for the prefrontal cortex, this is another part that important for the memory, where we know that it's the largest area in the animal, especially in primate. So it's involved in learning and memory, which connected to the medial temporal lobe, here, and the encephalic structure. The encephalic structure is up in the middle here. Okay. Okay. So this the importance of this frontal lobe had started in 1930s, where study done using delayed response tasks where they use monkey to do this experiment where they covered two identical well on the table, and then they will cover the well, and the when the animal one well they put food one well and cover both, and then they want the animal to choose which well have contain the food inside. Okay, so they run this experiment, and they try to switch left and right. So that's how this delayed response task is done. Okay, so for amygdala, there's another important area of the brain where it's regulate emotion, also fear and aggression. Okay, so normally it's involved or influenced by the stress hormone. Okay, so for example, when you have emotion involved when uh, of something, for example, you be sad for some reason. For example, you involved in accident, okay, and you feel so sad. So I believe that that will create more vivid or we call it strong long-term memory in your brain. So this is where amygdala play its role. And in early days, they use Pavlovian conditioning, where they combine these neutral tone paired with food shock. Okay, I believe that you know this experiment. I think it's more or less like active passive avoidant task. Okay, so when you see or the rat say the lights on or can hear the tone, and the rat will receive a food shock, electrical food shock. Okay, for and after a while, and when they just switch on the tone, the rat still freeze, not doing anything because in his brain he already know that okay after this I will get food shock. Okay, so that's what happened. So that's how they evaluate this amygdala function. Okay, and also it's just what I mentioned just now. It involves emotion, and yeah, it's very important for the transferring new learning into memory, long-term memory, and also it play a role in social and sexual behavior. Um, but again, it's always involved with emotion. So I think that's the most important keyword that you should remember about amygdala. Is there any question? Are you guys there? Any response?
Yes, Doctor.
Yeah, we're here, doctor.
We are here.
Okay. All right. Okay. So in this I would say in this lecture it's going to be like a lot of facts because uh I think you can read this in textbook and maybe you can Google it. Got a lot of information about this. But what I highlighted here is just like I try to make it like brief as possible, so for you to understand. But if you want to know more or in depth, so you can read textbook, okay, and you can read the history how they discovered this as well. So it's quite fascinating if you know that. Right. So next we move to the cerebellum. Okay, cerebellum at the back of your brain. Okay. So it's play a role in processing procedural memory, such as how to play the piano. Okay. So for example, if we call it implicit memory, where you have to know which how to move your finger, and after a while, maybe after if you didn't play the piano quite a while, you still have these kind of memories in your brain. Okay, and if you've been given a piano in front of you, you can play straight away. Even you might feel like, oh, it's been a while, I don't remember how to. But when you start to play, you can play because you have this implicit memory. We call it a procedural memory or motor learning and classical conditioning. It's very interesting, right? And they run experiment in the lab using a rabbit, where they puff air to the rabbit, but you know, normal rabbit will blink the eyes, right? But what they did was they try and damage the cerebellum, and then they try to uh, try to what is it to puff the air again, and the rabbit not able to learn how to blink the eyes. That's how they discover about this important or the role of cerebellum. Okay, so here come to the, I think it's very important part. I think you should know more about this because I would say hippocampus is the center of memory. Okay, so like I said earlier, it's situated at the temporal lobe at this area. Okay, so if it folded structure, of course, if you can see here, it's more or less like C shape. Okay, and this side. Okay, so now that's the where they give name for CA1, CA2, CA3 because it's come from coronal ammonis. Okay, or a seahorse. Okay, so that's the shape of the hippocampus. This is human brain, this rat brain. Okay, so you can read down here the pathway, how this hippocampus get the information. Okay, normally they got information from this area. Okay, to travel through the to preferred path to dentate gyrus. Okay, and then go straight to this side and then transfer again. You can read down here, I already give, or you can read more. If you want to know more, you can find this Levis paper. It's very interesting. So I'm not going to, because it's about process, so it's very complicated. But that's what you have supposed to know. That's how the information been taken out and being taken in and how they process it. Okay. Okay, so it's involved with declarative and episodic memory. I will cover this part later on in the memory part. And they found about this memory when they run experiment using various tasks. For example, object recognition and maze running. It's more or less like the maze that Leslie did earlier, but they tried to make it what we call it update or upgrade the method. They use water maze, for example, radial maze to evaluate the memory. Okay. So what happened if you take out the hippocampus? I would like to call a name, but I cannot find the list. Anyone want to answer this?
If not mistaken, memory will impact.
Memory will impair. Okay. Do you know what memory? It's okay that Nur Shaliza.
Yeah, the sites usually, if not mistaken, lah, hippocampus will taken out if the case, for example, like epilepsy. So, but the bronze the client in memory may be poor, not as before lah. Not sure.
Okay. Well, good try. I saw some chat here, but I don't know why I cannot open it. I prefer you guys to just use mine, okay? So then we can have a two-way conversation. I saw some
Yeah, doctor.
chat there. Who's
Is it-
speaking there?
Yeah,
Edward.
Edward, yeah.
Yeah.
So for if remove hippocampus, the memory that will be impaired is episodic memory because it's related to emotion and also learning. and also
Right.
experience.
Okay. Good answer. Right. So what you are right actually. So basically, what happened to this guy? This guy got epilepsy when he was child because I think he involved in accident, if I'm not mistaken. And then he start to get epilepsy. Over the time it's getting worse. And what they did, they take it out. I think more than half of the hippocampus, and the epilepsy is gone. But I mean, the side effect of it is he cannot have new memory, but he still got the old memory. He still can he still can't remember what happened before the surgery, but afterward, even when he watched a movie, for example, he cannot remember a thing. And even they give food, and then after a few minutes they give another food. He just keep eating without remember that he already ate the food. So that's what happened to him. It's quite interesting to know. Um, okay, I think we have a video here. All right, okay, maybe we can watch this video to get to know more about this HM patient. Can you guys hear this?
No,
Can you
doctor.
hear this?
No.
No, doctor.
No.
Mm.
Right. Okay. Let me stop sharing. I will share. Yes. Right. Okay. I think it's okay.
A cheap drill saw to
Can you hear
bore
it?
into a young man's skull, cutting away vital pieces of his brain and sucking them out through a metal
Yes.
tube. But this wasn't a
Yes,
scene
doctor.
from
Yes, can hear.
Good.
or a gruesome police report. Dr. Scoville was one of the most renowned neurosurgeons of his time, and the young man was Henry Molaison, the famous patient known as HM, whose case provided amazing insights into how our brains work. As a boy, Henry had cracked his skull in an accident and soon began having seizures, blacking out, and losing control of bodily functions. After enduring years of frequent episodes and even dropping out of high school, the desperate young man had turned to Dr. Scoville, a daredevil known for risky surgeries. Partial lobotomies had been used for decades to treat mental patients, based on the notion that mental functions were strictly localized to corresponding brain areas. Having successfully used them to reduce seizures in psychotics, Scoville decided to remove HM's hippocampus, a part of the limbic system that was associated with emotion, but whose function was unknown. At first glance, the operation had succeeded. HM's seizures virtually disappeared, with no change in personality, and his IQ even improved. But there was one problem. His memory was shot. Besides losing most of his memories from the previous decade, HM was unable to form new ones, forgetting what day it was, repeating comments, and even eating multiple meals in a row. When Scoville informed another expert, Wilder Penfield, of the results, he sent a PhD student named Brenda Milner to study HM at his parents' home, where he now spent his days doing odd chores and watching classic movies for the first time, over and over. What she discovered through a series of tests and interviews didn't just contribute greatly to the study of memory, it redefined what memory even meant. One of Milner's findings shed light on the obvious fact that although HM couldn't form new memories, he still retained information long enough from moment to moment to finish a sentence or find the bathroom. When Milner gave him a random number, he managed to remember it for 15 minutes by repeating it to himself constantly. But only 5 minutes later, he forgot the test had even taken place. Neuroscientists had thought of memory as monolithic, all of it essentially the same, and stored throughout the brain. Milner's results were not only the first clue for the now familiar distinction between short-term and long-term memory, but showed that each uses different brain regions. We now know that memory formation involves several steps. After immediate sensory data is temporarily transcribed by neurons in the cortex, it travels to the hippocampus, where special proteins work to strengthen the cortical synaptic connections. If the experience was strong enough, or we recall it periodically in the first few days, the hippocampus then transfers the memory back to the cortex for permanent storage. HM's mind could form the initial impressions, but without a hippocampus to perform this memory consolidation, they eroded like messages scrawled in sand. But this was not the only memory distinction Milner found. In a now famous experiment, she asked HM to trace a third star in the narrow space between the outlines of two concentric ones, while he could only see his paper and pencil through a mirror. Like anyone else performing such an awkward task for the first time, he did horribly. But surprisingly, he improved over repeated trials, even though he had no memory of previous attempts. His unconscious motor centers remembered what the conscious mind had forgotten. What Milner had discovered was that the declarative memory of names, dates, and facts is different from the procedural memory of riding a bicycle or signing your name. And we now know that procedural memory relies more on the basal ganglia and cerebellum, structures that were intact in HM's brain. This distinction between knowing that and knowing how has underpinned all memory research since. HM died at the age of 82 after a mostly peaceful life in a nursing home. Over the years, he had been examined by more than 100 neuroscientists, making his the most studied mind in history. Upon his death, his brain was preserved and scanned before being cut into over 2,000 individual slices and photographed to form a digital map down to the level of individual neurons, all in a live broadcast watched by 400,000 people. Though HM spent most of his life forgetting things, he and his contributions to our understanding of memory will be remembered for generations to come.
Okay, so that's the HM story. It's quite interesting, isn't it? So even you know that it's quite poor to him, because he cannot live normal life like others. But I mean, his contribution to science is very big. So that's how we understand how this memory, more about memory, and also the location of the memory. I mean, the special role of hippocampus itself. Okay, and yeah, that's how they run the experiment. It's been evaluated by hundreds of researchers. So, is there any question from you guys so far? Yes.
Doktor,
Uh-huh.
macam case that one kan epilepsy diorang akan removekan hippocampus tu ada lagi ke maksud dia maksudnya yang tadi tu adalah salah satu case study kan, so ada
Yes.
masih wujud ke case study yang diorang terpaksa
Remove.
remove
Okay. I don't think so. Because these days they already know about new technology and new medication that can treat epilepsy. And if I'm not mistaken, our department here, neuroscience in HUSM, they have this we call it deep brain surgery. Okay, so they will go straight to the area where they put. I'm not sure. What I think is electrode, something like that. So they will trigger the area to release a neurotransmitter uh, to reduce the seizure. So that's the modern or the newest technology that I know. It's from, I think, Dr. Prof. Zamzuri, who do the surgery. Maybe in his class you can ask more on that.
Yeah, thank
Yeah.
you Doktor.
Okay, any more questions? okay, I think it's better for us to know more because it's you are in trend, so you have to know what happened in past before you can create the future. So I think the next video, yeah, this is the video. I think it's better, worth to watch. It's quite long, but
Allow me now to introduce you to a true pioneer. This woman earned her first degree from Cambridge in the 1930s. By 1944, she moved to Montreal, expecting to stay only a year, but she never left. With immense determination and, as she puts it, intense curiosity, she has spent her career investigating the mysteries of the human brain. Working with the legendary Dr. Wilder Penfield, she challenged conventional wisdom and wound up creating an entirely new field, neuropsychology. Meet Dr. Brenda Milner, considered by many to be the world's foremost expert on memory. Brenda Milner was a Cambridge graduate when she and her husband came to Montreal from England in 1944. Milner initially taught psychology at the University of Montreal, but in 1950, she was enticed to McGill's psychology department by the arrival of Donald Hebb. Hebb secured for Milner a research opportunity at the Montreal Neurological Institute, working with the legendary Dr. Wilder Penfield.
That was June 1950. And of course, as soon as I set foot here, I got so excited by it that I knew this is what I wanted to do.
Milner's job would be to study and test Penfield's patients before and after surgery that removed part of one temporal lobe, a new operation done to alleviate epileptic seizures. Dr. William Feindel later became a member of that surgical team.
The preoperative testing, which she did, if she found the patient already had a memory deficit, we had to be much more careful with our removal at surgery because of that. So it's a very important and valuable collaboration in that sense.
I had become very, very interested. I was very well read about animal work and so on, and I had become very interested in the temporal lobes of the brain and you know how they might work on the basis of studies in monkeys. And so I had definite ideas I wanted to try out. I'm going to show you a group of faces, photographs of faces, and I want you to study them carefully so that you can remember them. So therefore, I thought I will look for some, this is my PhD, I will look for some visual perceptual deficits, and I will have a hypothesis that I might see this more strongly from the right side than from the left. Hebb didn't really, but he thought I was being a bit daring suggesting that.
By 1952, Milner had accumulated enough evidence to demonstrate mild deficits on certain perceptual tasks, mainly after surgery on the right temporal lobe, less so on the left. Her hunch was right.
And, you know, I had to fight to get this accepted because they were subtle and because nobody was really had this faith in the right hemisphere. I had this interest in the right hemisphere.
But what Milner did next would change the course of her career.
You know, patients would come to me, and especially the ones with left-sided lesions, and they would say, oh, I have such trouble with my memory. And I wasn't there to study memory, you know.
But she listened and observed.
If a patient comes to you and says, I have trouble with my memory, you should not reply, and I didn't. You shouldn't say, don't talk to me about memory. I'm here to study perception, or I'm here to study the motor system. Don't want to know about memory. You should be very quiet as a mouse, and you should listen, and you should say, what kind of memory? And, well, if this is what the patient feels is wrong with them after this surgery or after this epilepsy, I should study memory, you know? And so from then on, because the patients said they had memory trouble, I switched the focus of my research to memory.
She got very hooked onto this idea of memory and developed her own tests and her own techniques for working out the details of these memory things.
Milner was concerned and challenged by the unexpected outcome in two patients who had developed severe memory impairment after what had become a standard procedure for temporal lobe epilepsy.
So Heb had supported me for 1 year on his own funds, and I'd given up my tenured position at the U of M. Heb thought I was really foolish. And I didn't know what I was going to do at the end of the 1 year. But then when we ran into this memory problem, Penfield came to me and said, "We need you. You have to come." And he found me a little office at the Neuro and so on. But neither Heb nor Penfield gave me a penny for anything. If I wanted to do a test, I had to photocopy something, and I really had no money.
Milner pursued her methodical testing of Penfield's patients, and in 1955, Penfield and Milner presented their findings on post-surgical memory loss to the American Neurological Association. It caught the attention of a Connecticut neurosurgeon whose patient, known as HM, had suffered a profound and permanent loss of recent memory after a surgical procedure. Milner was asked to study HM, which she did over a period of several years, though HM never remembered her from one visit to the next.
I think one of the characteristics of Dr. Milner is her methodical, persistent, and very well-organized testing of these patients.
It was one such test, the mirror drawing test, that revealed to Dr. Milner evidence that the human brain had more than one memory system.
For all of us, you or me today, whenever you get to the point of the star where you have to change direction, your hand does this kind of thing, but then by doing, not by telling yourself what you ought to be doing, but just by doing in some way, by practice, you gradually improve and you keep a nice smooth line, and at the end it's beautiful. That is what you and I would do. But it's also what HM did. HM, over the 3 days that I tested him, and I have a lovely learning curve for this, that he got better and better, and he was doing beautifully at the end. And he had absolutely no recollection of the 3 days training he'd done on this. It was that one trial was unique to him, experience, and he was proud of himself that he had done it so well. No recollection at all of all that had gone before. And it was this dissociation, between his total lack of, between what he was aware of and what he had achieved. That was, to me, very exciting. If anybody asked me, the really exciting moment, it was actually then, looking with my eyes very wide at this going on. And this was early evidence that there's more than one learning and memory system in the brain,
Milner's insightful analysis of HM's memory deficit is known today to just about every first-year psychology student, notes David Coleman, director of the MNI.
She's been able to take essentially a single patient, this fellow HM, and by asking the right questions, tease out the fundamentals of memory in a way that no one did previously.
Milner's discoveries in the 1950s began attracting new students and postdoctoral fellows, and at long last, some research funding.
Here you have a pack of cards, and there are 4 key cards in front of you. And what I want you to do...
In the 1960s, Milner turned her attention to the frontal lobes of the brain.
Where you think it should go. And I will tell you whether
she used the Wisconsin card sorting task to reveal a particular deficit among patients with frontal lobe lesions.
Okay, go ahead. That's wrong.
Wrong.
No, you can't change it.
Oh, I can't change it.
You just learn from it.
Okay.
What the frontal patients were doing is going on repetitively doing this thing which was incorrect. Even though they were being told wrong, they were not shifting.
This test revealed that damage to the frontal lobes affects a person's ability to adapt to change, more so from damage to the left frontal lobe than the right.
This is the work that I had the most difficulty getting published, because the whole climate of the time was to play down the frontal lobes. This is very hard to imagine today, but it was in the 60s, 1964. And I had more trouble getting this work published than anything, and yet it has been very influential. So I'm quite proud of that, actually.
The thread running through Brenda Milner's research has been the complementarity of the left and right hemispheres of the brain. When she started her research career, conventional wisdom said that the right hemisphere was a bit of a spare tire. That didn't ring true with Milner, and she pursued a methodical testing of patients to reveal the unique functions of the right hemisphere.
standing up in New York at Eastern psychology meetings with these wolves. This is where, this was I didn't have to fight Dr. Penfield about being a woman or anything. Never had to fight because I was a woman. But the fact that I was daring to claim something for the right hemisphere in New York with this crowd of eager, self-confident young psychologists and their professors was tough, but I believed it. I believed my observations.
So Brenda is an extremely clear thinker, and she's very persuasive. When she's convinced of something, she can argue very effectively on the behalf of whatever she's convinced of. And she's also an extremely keen observer. So you make that combination, and you have a formidable scientist.
Milner's many research breakthroughs were so groundbreaking that they led to the establishment of an entirely new discipline within the field of psychology.
She's often given credit for establishing what we call clinical neuropsychology, that is, psychology directed toward patient care and understanding patients' behavior, as being one of the individuals who have been largely responsible for developing that field. And if you look at many hospitals all over the world, the individuals who are doing patient testing and examination of patients from a psychological point of view have been trained here at the Neurological Institute by Brenda and her successive team who've followed her.
Her contributions to memory probably would not have been done by anybody else. And I think that's her uniqueness. She's recognized as the world's authority on memory.
At 90 years of age, Brenda Milner is still actively pursuing her research and passionately sharing her experience with students and faculty.
So I suppose more than any single finding, I look around our group, our cognitive neuroscience group, it's really big, and I look around the people around the world who trained here with me and with my younger colleagues, and I think I'm proudest of that,
If it weren't for Brenda Milner, using this unique model that she recognized was a unique model, we would know much less about memory, the psychology of memory, than we do today.
Wrong.
Okay, so that's about Milner. I would say that he is a mother of memory because he's been doing this for ages in 1950s. So so there's a lot of improvement that she did, and of course from the video you can see that the challenges that she has to face, up until now, discrimination and whatnot. Right, I think it's quite informative video. So I hope you can get some take-home message from there. So that's for the first part of the brain. Is there any question from you guys?
No, Doctor.
Right. Okay, so we still have 22 students here. Okay. I would like to ask a question I want to hear from Muhammad Firdaus. Muhammad Firdaus, are you there?
Yes, Doctor.
Okay, I want to know what color of your shirt that you wore last 2 weeks.
Last 2 weeks. On what day, Doctor?
On Wednesday.
Wednesday.
Do you still remember?
No, I'm not sure. But I want
Right.
to have 3 shirts.
Right. Okay. That's good to know. Okay. All right. Thank you, Muhammad Firdaus. Okay. Who's next? I would like to hear from Jing Hu Go. Hongo. I am not sure if I pronounce it right. Ying Hongo, right?
Hi, good afternoon. Yep.
Hi. Okay. Who's the last person you called today?
I've not called anybody today.
Right. Okay. Yesterday.
Yesterday, my goodness, I don't remember if I've called anybody. I would
Really?
say I don't think I've called anybody.
Right. So you're sure
I'm
there
pretty sure.
no
Yeah,
no information in your memory about
like
it?
90% sure.
Great. Okay. I like your confidence. Okay. Who else? Hanisa.
Yeah, doctor.
Okay. Where's the place you celebrate your birthday last 2 years?
The cinema. I went to watch a
Wow.
movie.
Okay. So it's really like vivid in your mind.
Yeah.
Okay. That's good. That's good. Thank you. Okay. Who else? Muhammad Azmarul.
Yeah, doctor.
Okay, do you know or did you realize what you can see on your coin, 50 cent? What you can see there?
There is a number of 50
And
on one side, and the other side probably hibiscus flower.
really, are you sure it's not on the same side?
Not that I'm aware of, to be honest.
Okay. Okay. Thank you. Right. Okay. So why I asking you this kind of question, because we know that um our memory, we got few part of memory that what we can say that, or what we can categorize into, depending on how long or how far you can remember something, or how you take this information and transfer into to the memory. Okay, so that's where we are going to um, today. Let me share this. Okay. Right, can you see this? Yeah.
Can, doctor.
Okay. So now we focus on the memory. Okay. So I told you earlier. So it's it's a process. To be honest, it's a process of how you store your information, or the information that you learn. Okay. So in a specific word, we can say that process of encoding, or storing and retrieving experience or knowledge that you gather. Okay, so from the videos you saw just now, you watched just now, when someone do the surgery, for example, for whatever reason, maybe because of the accident or trauma or epilepsy, um, so the brain is, the brain still can function. Okay, so that's what we call it as a neuroplasticity, because it's plastic. So when you say plastic, so you can change. Okay, the form can change, or what we can say, the pathway can change to the original pathway to a new pathway. So it might not be perfect like previously or originally, but it's still, the brain still can process the information. Okay. So the combination of neuron that reactivate over any other combination of neuron. So again, like I showed the slide earlier about the chain reaction. So it's more or less the same. So when neuron fire at one side, or one area, so it will fire to another area, but it will change, or it use different pathway. Okay, so it's also depending on the neuron itself. So if you have two neurons, for example, one neuron keep consistently firing, and the B neuron take the impulse, or say the information, and start to fire together. So the connection between these two neurons is getting stronger. But if the B or A neuron fail to fire B neuron, so that's what you can see, a weaker connection between neurons. Or you can call it as a LTP, long-term potentiation and long-term depression. So I'm not going to share about LTP and LTD here, because I think it's been covered. Or maybe if you actually, the next semester we are going to offer subject on the plasticity and memory. In that topic, we covered a lot of subtopic involving plasticity and memory, and we are going to learn very detailed how this happened and what element that involved to create the memory and also the plasticity. And that will be covered by me and Dr. Harizal. And also from, I think Dr. Faiz also will contribute some of it. Right. So if you ask your, for example, your, I don't know, your brother, maybe 5 years old brother, so what he think about house. So maybe he think about, like, the drawing that he draw house before, for example, because this is very, like, the neuron is not that developed, or they don't have any other information. Say, for example, the he didn't have any experience before, which attached to this house. But within time, say for example, after 50 years old, 50 years later, maybe you can have, when you say about house, this is what you imagine about the house, because it's evolved experience. For example, maybe that's the house where you get married, for example, with your spouse, and where your parent die, for example. So you have this kind of emotion that involved, that we contribute for the memory formation. And you have other pathway rather than just like simple pathway, like from neuron A to neuron B. You can go to neuron C or D or E in the house. So this is what been explained down here. You can read later on. And like I said, we got in general 3 type of memory. It's working memory. It lasted for like a few seconds, just like a blast in mind, for example, or what you can say, just for sekali lalu, and after that you will forget about it. Okay, like what I did just now. So, or like you feel like deja vu or things like that, but then it's gone. But this memory, the working memory, can be formed into short-term memory. It lasted about a few seconds to maybe 30 minutes, for example, and it's require rehearsal or repetition of the working memory. For example, you try to remember something, but how you can memorize things. You do the repetition, or you, for example, you want to know about something, and then you read once, and you want to store it as a short-term memory. You read more, second time, third time, and then it will stay in your short-term memory. Okay, and also short-term memory can transfer to long-term memory, or it can go fading, like faded, like you will forget about things that you remember for the past 30 minutes, for example. You forgot who the last person you called, for example, because maybe it's not important for you, or maybe you think like, maybe you are in rush, for example, so your short-term memory is not developed there, or it just go, just fade. And for long-term memory, it will stay in your brain months or years. You can still remember when you were small, say for example 7 years old or 8 years old. You still remember all the events. Maybe you ride a bicycle, you fall down, and things like that. Okay, it's involved. If it's involved motion, that's what will enhance your memory. Right. So when you got this information, or we call it sensory input, okay, you will this input will encode it. Okay, will change into we call it as a form that your brain can store. Okay, so it can be like visual or sound, or maybe some meaningful for you, and it will store in the brain, and it will you can retrieve the memory. That's what memory altogether. So you have to have these three step, or three what we call it procedure, in order for you to form a memory. Okay, so like I tell you earlier, so your memory can form from can be created into one type of memory to another. For example, here we're talking about short-term memory. You have the sensory information, you encode the information, and then you store the information, and you retrieve the information, or you do the consolidation. Okay, so you can have this information again when you try to remember things, and for another situation where the memory gone, faded, because there is no link between short-term memory and long-term memory. Like I said, maybe because of the event is not important for you. Maybe you just don't want to think about it. Maybe, for example, you try to say what you got a phone call from scammers, for example, or unknown caller, for example. So you don't want to think about it, and you just like leave it. You not even save the number, and it's gone. But if there is a link between short-term and memory, then it will store the memory into long-term memory, and you can always retrieve the memory again and again. And the more you try to retrieve, the longer the memory will stay in the brain, specifically in the campus. Okay, so long-term memory, you have two type of long-term memory. You have declarative memory, or we also call it as explicit or conscious memory. Okay, this memory that you collect or during your conscious. Okay, for example, you celebrate your birthday. Just now your friend said, "Oh, I went to cinema from last two years." So maybe there is something like it's very special for her. Maybe the movie is so good, for example. Maybe she went there with her boyfriend, maybe, so it's very meaningful. So that's how the declarative memory will form. Okay, you always remember that, and you keep, oh, I like this, oh, it's very sweet memory, so I want to remember this for the rest of my life, for example. So that's how declarative memory. So you do it consciously. Okay, but this type of memory can be faded as well, uh, for example neurodegenerative disease. such as Alzheimer's. Okay, you have if you have the disease, you forgot things. And also, if you do stress, okay, some of the stress protein can also affect your memory as well. Okay, so this declarative memory have the two type: episodic, where the memory relate to experience, I told you earlier, holiday or birthday. And another one is semantic, is general knowledge. For example, who is the what is it, the president of America, for example, the prime minister of Malaysia. So that is semantic memory. So you know it for general knowledge. Everybody knows about it. So it and it's fact, it's always there, and you always can refer to textbook or you can Google it. So that is semantic memory. But again, these two types of memory can be formed when you are conscious. Okay. But when you're unconscious, that's where this non-declarative memory comes, where you learn tasks automatically. You didn't plan to do it, but you just do it. Okay, and it's also known as a implicit memory, and you just do it smoothly. Okay, you not even know how to. You not even learn how to do it. For example, a baby, they don't learn how to drink a milk, but that's natural how they do it. Okay, so they have can be divided into four types. Procedural memory is about skill, habit, and behavior. Uh, like play piano. Okay, after a while, okay, if your amygdala is fine, still okay, and everything, uh, you still can play this piano after a while. And you still can ride bicycle even after ages not uh, ride bicycle. Okay. So that kind of memory that we always store in your brain. Okay, you don't have to learn or do it every day, but you just got the skill. Okay, and another one is classical conditioning. This is normally for, well, what we can relate to this type of memory with experiment that have been done in the lab, where they have two stimuli. When you ring a bell, and the dog will secrete the saliva, because uh, he knows that that time is time for him to get food. And when you still ring a bell without the food, the dog still secrete the saliva. So that's the classical conditioning. That is perceptual representation and non-associative learning. Okay, so non-associative learning is normally for example, you are in your house, say in Kuala Lumpur or Selangor, next to MRT station. You always hear this, the noise from the train. But after a while, you become, habituate. Like you feel nothing about it. Maybe the first few months you feel like, oh my god, I can't live here because it's so noisy and all. But after a while you get used to it, and that's where it's come to habituation. Also same to for sensitization. At first you exposed to the stimuli, so you feel so annoyed, and then after a while it's become habitual. Okay. Is there any of you remember what's going on when you were 2 years old? Anyone?
I do.
Who's that?
Anissa here.
You don't remember anything.
I do remember a few things.
You do remember when you were 2 years old.
Yeah.
Okay. What you remember about?
I remember my parents taking me to the US
Okay.
because my dad had work over there.
Okay. Right.
Yeah, and I remember meeting some kids at the playground and what I ate at that time.
You were 8 years old.
2.
2
But
years
I
old.
said I remember what I ate at that time.
Oh, 8. All right. Okay. Wow. You have a very amazing memory, I would say. So because normal people, we have infertile amnesia. So what is infertile amnesia? Is we normally don't remember what happened. Maybe 1 year old or 2, or maybe less than 5. Some people up to 7 years old. He or she don't remember anything before that. What happened? It start from like 3 or 4. Then that's where the memories start to develop, and this happen because of the development of the brain itself. Okay, when we are when we are baby, so the brain is not fully well developed. Okay, and also I would say that during that time, we always sleep. We need like 12 hours sleep, because in our brain we do have injury neurotransmitter more than when we are in adulthood. Okay, so that's why your brain not didn't form this memory, because we need to have excitatory neurotransmitter in order for your brain to create new memory or learn thing and being transferred to a memory. So that's how this happened. Okay, and when we are getting older, so our synapses will reduce up to 50%. So maybe we already forget. Okay, we don't remember things, and because of the synapse stronger, when during the development, but after a while, maybe when we reach old age, so these synapses start to reduce and start to the memory will start to fade. So that's why we don't remember when we are old. So that's come Alzheimer's, dementia. So, but I mean, during childhood, so this is what happened. Okay, but maybe special for Anissa, maybe your infantile start when you are only during 1 year period of baby, and and after 2 years you start to develop this kind of this memory. Well, again, it's depend on the experience as well. Maybe your parent always exposed you to, for example, flashcard, or books, for example, or to develop your motors sensory as well. To look at the colors, the shape of something, by touch, by walk, by your sight, or maybe when you smell something. So when your parent expose you at very early age, so maybe you can develop this earlier compared to normal people. Okay, this is the answer to, I don't know the name, the guy earlier. Is it Amzarul?
Azmarul Lota.
Azharul. So this is 50 Cent, Azharul. You got high speakers power at the same side of 50 Cent, and another side you got, like, I don't know, this kind of chorak, maybe sort of trees or something. So
50 Cent and 20 Cent are not much different.
with what?
With 20 cents.
Yes. And the size also more or less the same, right?
Yeah.
Yeah,
I don't
because
like
I
to
also
point out.
I have trouble, whenever I want to pay, so I take some time to differentiate with 50 cent, 50 cent with 20 cents. So because of the shape and the size. But I mean, well, what I want to portray here is like, even it's happened in our daily life. We take things for granted. We don't know. We don't really look at the coin. Oh, this has hibiscus flower here. We got what is it, year there, or Bank Negara Malaysia there. We don't really bother about that thing, or even notes as well. But some people, when they have attached to something, okay, when it's involved with emotion, for example, maybe things happen. For example, adik dia tertelan this kind of this coin, for example. Oh my God, this 50 cent is very bad. Okay, so I will remember you for the rest of my life. So you identify the 50 cent. Oh, you got this, you got this, you got this. So okay, I will remember you 50 cents. So beware. That's kind of thing. So you're creating information, and you store information in your brain, and you always retrieve the information. Okay, you always consolidate the information, and that's what it forms strong memory, I would say. All right. Is there any question?
Doctor?
Yes.
Yeah, Mani here. Just wanna maybe can further explain to us so that we can understand the, I would say, difference between working memory and short-term memory.
Okay. Working memory and short-term memory is all about time. Okay. Working memory is like flash of what we call the happen, blink of eye lah, macam tu, macam a few seconds, and that's it. You forget it. But for short-term memory, it get longer. You can store longer memory, up to maybe 30 minutes, for example. But you can transform the working memory, okay, into short-term memory by doing repetitive or rehearsal. Okay, like as I told you earlier, when you read something, maybe your notes, just go by like very quickly, briefly. Oh, it is about this and this, and then you put aside. Do you remember everything what you read just now? Like after maybe 2 minutes, I believe that you will not remember everything. But when you read again, like 2 or 3 times, I believe that you are at least up to 90% of what you read you can store in your memory. But again, say if you want to pass your exam, okay, that's why that's come for revision. And how you train your brain to do the revision? Just read, or you need something else. You need colors, for example. Maybe for my lecture note, okay, you can find colors, or maybe that colors will you can store in your brain. That's where come the visual. Your brain store the information as visual. Okay, maybe you want to make it like brain mapping. That's how your brain can comprehend with that type of notes, for example, because you are visualized. You are like when you do brain mapping, you put everything there, and then you scan, and then you store. That's how your brain works. So it's all about how you train your brain. Some people don't know how to train the brain. Just leave as what it is. Oh, lupa lah, tak payah baca lah, Like examination is not that, important, for example, or dah sekali actually dah faham dah 100%, for example. So that kind of thing, you don't want to do that, as a student, okay? You need to understand, or you need to absorb everything in order for you to answer the question during your examination. So you have to, you want to read, you want to write, or maybe you want to make exercise if you have that, you find that kind of exercise in textbooks, for example. Right. So this is some of the natural way how you can improve your memory. Eat less added sugar. You can take supplements such as fish oil, omega-3 from fish. Okay, and make time for meditation. That I believe that we have, all of us have religious, so we in our religious we have this kind of meditation, or we call it prayers. Okay, you have your own time, that you meditate, get yourself, center, like not go that far from what you think, or just to need to calm down yourself or rest your mind, close your eyes, for example, and then after a while, getting better, and then you start to think straight or rational. And this kind of meditation always help for your memory, especially for working memory. And of course, healthy, way. Get enough sleep. If you, well, this is what happened to me. It's not happened to me, but what I saw during my study. Some of the students like to, read or do revision very last minute. When they have like examination tomorrow. So today is the time to study. So you start to read and read and read until like, I don't know, 6 a.m. in the morning. They didn't sleep, and then the next day sit for examination. Do you think that they asked them to do that? So actually, not enough sleep can make your brain block or blur, because your neuron cannot, the synapse is not in a very good condition, or we can say that your brain is tired, you cannot take anything anymore, and enough. So some of the students become like, oh my God, I forgot everything. I don't know what I read last night. Say that's, for example. So you always need to have enough sleep. And I would say that I also found that a few of my friends also like to sleep. They just sleep, and then they wake up and sit for examination, and they got good mark for that. Well, some students have that kind of gift, I would say. But again, if you sleep more than what you're supposed to, you will make your brain cell, lead to brain cell death as well. Because when you sleep, you get not enough oxygen, and then tend to the cell death, the brain cell death. So you don't want that as well. Okay. Practice mindfulness, like I said, maybe for meditation. Maybe you go for a walk, or what we call it, exercise. I remember there's a time when I did my PhD in the UK. When I ran my experiment, and my experiment is quite long procedure. I have to prepare the rat with the surgery, and before I can insert the electrode into the brain. So it's quite long procedure. So I start quite early in the morning, and we finish very late in the evening. So halfway, what happened was, once my rat died during the recording. My recording is about total is about like 3 hours recording, and my rat died. I feel so stressful, like, oh my God, uh, I cannot think straight. And what my supervisor said, okay, Harizal, just stop, just tidy up everything and just go walk to town, do shopping or something like that, because when we do that, we try to decrease the stress level where, this some stress protein will reduce or decrease your memory performance. So that's why it's always good to have like stay calm, and then you will do it in a good way. Okay. Right. Next is less drink alcohol. That's I believe that you know that. Train your brain. Okay. Some people like to do Sudoku. Okay, that's how they train their brain. I think Japanese like to do that. They always play. Or where we can say they train their brain, so to reduce dementia or Alzheimer's, because they keep the brain working and keep producing what we call it good hormone to support or to enhance or to strengthen the memory. And the number 9 is food. Okay, so you know what good for your body. So I'm going to elaborate more on that. Vitamin, okay, exercise, and again food. So you need all this kind of supplement or food that can help to reduce this stressness, or reduce this bad protein that can contribute for the memory deficit. Sorry. Right. I think that's all. I'm not going to play this video. You can watch this video in YouTube. There is kind of summary of what about memory altogether. So I think that's all. Is there any question? Any question?
Hi, doctor.
Sorry?
Hi, doctor. I got a question.
Yes. Go on, Edward.
In the slide just now, you mentioned about during childhood, there's no the development of episodic memory is very minimal. But what about other memories such as procedural memory, things that you learn during infancy or childhood? Is it the same?
Yeah. Okay. It will how we say that? It will store, because within time, okay, your brain will develop memory, okay, but not until that at certain to the extent where you have this very strong link of memory, to be stored. You still build up the memory, but it's not stored yet. Maybe up to the encoding, for example. But after your synapse develop, okay, you got more synapse connected to to neuron, more neuron. So you will develop the link, or what we call it pathway to transform this information into memory. So that's the condition during the when we are baby. So you have to take consideration of the development of the brain itself, and also the neurotransmitter in the brain. So, and also the synapse, of course, it's the brain development. So when you have more synapse, you can create more memory. But it's built up, okay? It's not like, because of course, it start from zero, and it will continue on and on and on. So yeah, I think I answered that question. Edward, is it okay?
Yeah, thank you, doctor.
Okay. Any more questions? Right. Okay, I think that's all. I'm not going to give you guys assignment today. Maybe in another like 2 or 3 days. I have to prepare what assignment that I want to give to you. I do have some in mind, but I would say that I would like to combine between these two subtopic, memory and the brain, and with the development of the brain. That's another class that I have to share with you guys. So I think of combine that both because for my part, I've been given a responsibility to take marks from the written assignment and also presentation. So I think 10% of each. So that will contribute 20% for your final marks. And I think you guys already have a group from Dr. Hafidah class. Am I right?
Yes, doctor.
So how many of you in a group?
3 people?
3.
Yeah,
So you have a 7 group altogether, right?
I believe so, yeah.
Yeah. Okay. Right. Are you guys want to stay in the group or you want to form a new group? Majority? What say you guys? Because maybe already like suitable, like
Same
comfortable
group.
with
Same group,
same
Prof.
group. Okay. Okay. So yeah, I think better that way because so you already have a connection. You know how to work with your friend. Otherwise, you have to start from scratch again. Right. So if that's so, I'm going to give you guys the what we call the title, what assignment that you should do, maybe in 2 or 3 days. And I would like to have it in written assignment, and also I need you guys to present it during the tutorial class. Is it okay? Is there any objection for that?
Doctor, that means
Yes.
that means the assignment will be only one, but it has to be submitted
Written?
both
Mhm.
written and also presentation, right?
Yes, that's true. Yeah.
Okay.
I will mark that the written assignment, and for the presentation, I will focus on your individual presentation. Okay. For those who already who was in my class for genetic, they know what I'm looking for. So I like you guys to have informative and attractive slide. I'll try to avoid words. Maybe you can put diagram or chart, which is easy and like to read when I hear a presentation. I like to look at the presentation. Uh, what we call it, a bit no for me, to be honest. Maybe some of the lecturer is okay with it, but I don't know. I don't like it. And even though you are not, you try to deliver something, but it's not very smooth. But that is fine. Um, I want you to be confident. I want you to um, deliver in your own word, because I believe that when you do that way, people will understand easily rather than read and like some terms we don't know what's that meaning, but when you deliver in your own word, so we know better. So that's for my part. Yeah, I think that's all. Is there any question? regarding to the assignment, I might post that in eLearn. So, and also this slide presentation, I will post it there as well.
Doctor, can I ask a question on the memory?
Yes.
Okay, with regards to the memory, I notice a lot of people, they tend to fall back onto their bad memories. That means they have some sort of depression or stress looking at some of those bad things that have happened to their life. They don't want to look into all the good things that have actually happened. So how can they work on their memory in order to like forego the old memories, which actually like withdrawing them from the society or actually creating a bad impression of themselves?
You mean how to delete that bad memory in other words?
Yeah.
Right. That's very interesting question. I never thought about that. Actually. What I would say when we talk about memory is you have encoding, you have storage, you have retrieval, and or a consolidation. I would say if you don't want to remember that bad thing, you just keep that part retrieving or consolidation, which means that you didn't transfer your short-term memory to long-term memory, so you not consolidate, okay? Or even it's been already transferred to your long-term memory, so do not retrieve it. In other words, try to not remember it. Try to, how to say, when it's how to say, when you have something to trigger you to remember that bad experience, you might want to think to you want to divert your thinking to other thing, happy thing, for example. Okay, try to, or maybe you can take it, some people take it like positive way, maybe you don't want to remember, but maybe when you think straight or you want to think, try to be positive, I would say, like then you will turn that bad experience into a natural or normal way.
Okay. All right. Thank you so much, Doctor.
Yeah, I think I can relate this from my experience as well. In 2015, my mom died when I was struggling with my PhD. So it's very frustrating. Like, oh my God, I feel like unfinished business, like what I did for my mom, and things this happen, and I quite depressed, to be honest. But what I did, like, I tried to think positive. Maybe there's a, better side of it. But how I overcome, I do, I create new hobby. I talk to people. Try to avoid to talk about it. So I'm not really like, I'm not talking about my mom or things like that for quite a while, and because you don't want to bring that sad memory. So try to not to retrieve that memory. So I think that's from my own experience. Maybe you can have a specific way to do it with psychologists, I would say, or counselor. Maybe they have special method to do that. So yeah.
Yeah. Thank you so much, Doctor. Thank you.
All right. Welcome. Anything else before we end our
Doctor?
session? Salini, yes.
Yeah. Doctor, I have a question. How about photographic memory? Can we develop photographic memory?
Yes, like I presented here. So when you have this kind of sensory input, so you have this kind of how you translate the input into in your brain, or how you encode the input in your brain. So the system will how to say it, install in your in your brain, or you can say. So when you do something like what I said, maybe from the slide, okay, oh my God, it's a lot of work. So you want to translate that slide into a photo or diagram, for example. and you picture it as a visual. So that's how you encode the notes as a visual, not as a text, for example. Okay, or maybe you want to record. So when you have this slide, you record it, you read it again, and then you record, and then you play it again and again and again. So it will store in your brain. Okay, and maybe some people just semantic. They have like, oh, they understand about this memory now. Oh, so by you put this, a lot of meaning. You understand the meaning of the system, for example, or the part of the brain, hippocampus, amygdala. So you already store that information, okay, by the meaning of it, to understand. So what you just do is you just have to retrieve the memory, or you just think, just close your eyes, for example. Okay, the photos or the diagram will come out, or okay, like this. Like maybe you can put colors for it to trigger your memory to remember. Oh, when you think of rat, for example, so it's come out. This diagram will come out. So that kind of thing. So that's actually can be your strategy for to answer or to make notes. Okay. For your examination. Well, because of course, when you study biology, for example, biomedical, you have to remember a lot of things. You have to remember the meaning, or the justification of it, or the hypothesis of some theory. Okay, you have to remember everything. So it is that kind of step that you can do to enhance your memory. Okay, Senik?
Thank you.
All right. Okay, I think that's all. We finished quite early today. Okay. You have any classes after this? Or that's it for today? No more class?
We have statistics after this.
Yeah, we have class later.
Right, okay. And I think that's all for today. Thank you for your attention and participation. And I will let you guys know when I post that assignment. So I see you guys later, maybe in the tutorial class. All right then. Thank you.
Thank you,
Bye.
Doctor.
Assalamualaikum.
Bye.
Bye.
Thank you, Doctor.
Okay.